Hi, I'm Dave Shook. We're going to be talking today about different types of operational data. This is a continuation of the last talk. I want to talk about specific types of operational data because there's several, and they the fact that different ones exist and how many there are kind of makes life a little bit complicated. First of all, the single most common type of data that people think about when they talk about operational data is what we call time series. And time series data is the data that comes from instruments or that goes out as commands. And the thing about time series data is that there's always an identifier, which we typically refer to as a tag. And then it takes on values over time. So it's a time series, and it's always within the context of a single tag or possibly multiple tags together, but one time series is one identifier. Now, the way this data comes in is in packages consisting of an identifier, a timestamp, a value, and a quality. And the thing is that the quality tells us whether the value itself is of any use, and if not, why not? But it always comes in this sort of bundle of data. Now, alarms and events are quite different. They can be things like high temperature, or they can be things like batch complete. And the thing is that alarm and event data is not structured the same. It doesn't have a single identifier and a single timestamp. Often these things will have a start time and an end time. And just the fact that it's set up with an interval means that it's not a time series. Also, what happens is that there'll be some sort of object. It might be a batch, it might be an instrument, it might be a piece of equipment. There'll often be some sort of topic, alarm, or even high alarm, low alarm, high alarm. And then there'll be a bunch of values, and the values are a function really of the topic. So we now get into this world that's more sort of relational in structure than the simple structure of a time series. To carry that on, to look at a vibration monitoring system, which is more like an IoT device, what we have here is we'll have an identifier, and that'll be for the sensor or the location. But the problem is that it doesn't send raw data, because the data that comes in here might come in at 10,000 hertz, so 10,000 values a second. So it doesn't make sense to send all that data up to the cloud. Instead, what it does is at some timestamp, it will put together a bundle of data, like an array of 2048 raw values, a Fourier transform or power spectrum, which is 2048 outputs, plus a bunch of features. And the features depend on configuration as well as the specific manufacturer and model. These are things like total power, or what frequency the biggest peaks are at, that kind of thing. So this is a much more complex data set than the alarms and events, and far more complex than simple time series. And this is just one example of the type of complex data structure that can come up from operations. Now, in addition to this, there is metadata. And the simplest form of metadata is, for any given measurement, right, is the engineering units. It matters whether this is in degrees Celsius or degrees Fahrenheit. It matters whether it's in feet per second or meters per second, and so on. So engineering units, there's also things like validity limits. A lot of instruments have hard limits on minimum and maximum that they can measure accurately. Provenance, the origin of the data, is also important. So this metadata is really associated with any single measurement value that comes in. And it does change from time to time, so we do need to retrieve it. And finally, there's something called context. And the issue with context is this: if we look at this vibration monitoring system, it is configured to understand that these two bearings are at 90, these two vibration sensors are 90 degrees apart on a particular bearing, that it will probably be configured to know that these two bearings are on the same pump. It may be configured to know that these bearings on this pump are connected to a shaft from that motor, which has these measurements as well. That's as far as it goes. The context information within the vibration monitoring system knows nothing about the process context. It only knows about the equipment context for the equipment it is monitoring. But for us as engineers or people analyzing what's going on, the process operating context is as important as the equipment context. And so the problem here is that each source system has a data model. But there's more than one, and they overlap because they refer to the same physical environment. They are not necessarily configured in such a way that they know about it, and they're not necessarily configured consistently. So this context information, these data models also need to be acquired and brought up to the cloud. So here we've got 5 quite distinct types of data. We've got time series, we've got alarms and events, we have a complex sensor device record, we have metadata and context. That's a quick review of the types of operational data that you encounter. I hope you found this useful. Um, Please feel free to look us up at uptakefusion.com and see other videos that we have posted there. Thank you.